Hey guys, David here and welcome to another Dark Art Guitars video. Today I'm pulling back the curtain and showing you my process for designing guitars inside of Fusion360. Now this is not a direct tutorial of step-by-step how to build a guitar. That would take a lot longer. So instead in this video I'm just going to give you some tips and tricks that are going to be useful to take your already existing Fusion knowledge to the next level and just get better designs and more easily, quicker, and that are more adaptable as well. Now I'm going to assume that you are already somewhat familiar with Fusion. If you've never used it before and want to get into it, then there's many great beginner series out there. It doesn't matter what they're targeted to, you just need to learn the basic tools of sketches, extrudes, constraining your sketches, all of that stuff. If you don't know that before starting a guitar build, then you're going to be in for a world of trouble, as there are a lot of components that quickly add up, and if you don't have the fundamentals down, then it's just going to be one big mess. But if you want to still have a guitar file that is fully functional without having to model it completely from scratch, for the first time ever, I'm actually releasing a fully featured headless guitar design. Now, I have modified it slightly from my designs, as well, I do sell those as built guitars, so I don't want to give you one of these direct design files where you can just send them to the CNC and build an exact copy. Instead, I want to motivate you to take, well, the complicated bits of modeling, all of the joinery and all of the everything, but then just modify the shape, create your own headless shape. It doesn't have to be worlds different, just a little bit different, and that way we can continue to evolve and everybody can have kind of their own look. So that is basically the only thing that is different. It's just the outline shape compared to the models that I use as well. It also has some basic configuration options here, like you can switch between fixed bridge, tremolo, and then when you select that, it will automatically just kind of play some tricks in what it hides and unhides in the timeline. I will go more into that later. And then here you can see that's the tremolo option, and you can have it active or passive. That just adds or doesn't add to the battery cover here. Now, of course, you can also go into all of the details here and start to suppress features and unsuppress stuff. Like there's one version that has partial scallops here. Then, for example, if you don't want any scallops, you can just simply suppress these features, then you don't have anyone, and there's also one that has complete scallops, stuff like that. The bridges that I'm using here are from Nova Guitar Parts. They're a really good kind of entry-level bridge. It doesn't break the bank, but it is high quality, so even though it doesn't cost that much, you still are not going to be lacking any features, and it's not going to be a pain to tune or anything like that, as you get with some of the very cheap import bridges. So I use them on a lot of my builds, not quite all of them. Sometimes I use different bridges, but for the most part, when people just want a decently priced option, I would go with Nova Guitar Parts. No affiliation, by the way. What you can also change in here are a bunch of parameters, like for example scale length and various other things like that. However, changing some of those will somewhat break the model in some cases where you have to go back and fix a couple of steps. But I will show more about that later in the video as well. I just want to show you that you are not stuck with the basic design. It's quite adaptable to as far as possible. I made it parametric, but with such a complicated design, it's not always possible to keep it fully working all the times. Now, if you want this design, then I have a link down below. It is available on my web store, and for the first week after this video releases, it will be 50% off. And I'm also making just the fretboard itself available. If you want to build the rest of the guitar manually, then that will be available for a cheaper price. But like the whole guitar already has that file basically baked into it, so you don't need to buy that in addition. Now, enough advertising for myself. Let's get into it. And most of these techniques I'm showing can be applied to basically any design. It doesn't have to be a guitar, especially it doesn't have to be a headless guitar. But I'm just showing them as examples on the guitars that I modeled, as well. A lot of you might be interested in that as well. But if you want to model something else, you can still use these techniques. The first one I want to talk about, as many of the other ones I will also mention, just goes to how can you model something in a way that agrees with Fusion, that doesn't create many bugs, that doesn't create weird geometry, and that doesn't make your Fusion crash. There are often a million ways that you can model something here in Fusion. However, some ways are preferred over others. And what I specifically want to talk about is kind of the different operations that you can do to create a 3D body. I'm going to assume that you already have a sketch or a geometry in mind, but then what do you choose? Do you extrude it? Do you sweep it, loft it? Do you go into the surface or mesh tools? Now, the basic hierarchy in terms of kind of how stable the feature is, how parametrically reproducible it is Extrude is the best. You just have a geometry and then you say how far, all of that good stuff. And unless you go into the sketch and start deleting lines, it will basically not break. When you start deleting lines, you may have to go back into it, reselect some stuff, but even that then easily is fixable and you basically no way to screw it up. Couple of quick things inside of the extrude menu. Most people will just use it like this, and if I don't know, show some sort of sketch here, if you have the main outline, just select something and extrude it however far you want. But there's actually a lot of features in here. For example, you can not just start at your sketch line, but you can also have a fixed offset that just gives you a value, where I could say 5 millimeters later. But the much more powerful one is object. So you can just say that you want to start at this height. And then it starts at this height. And if you further back in the timeline move this object, or this object becomes higher, it will also adjust it and it will start higher. So if you don't want to start at a sketch plane, choosing object is always the better option compared to offset, unless, well, there's no object that you can reference. But even in object, you can still have an additional offset. And then in extent, you have, once again, you have the distance, which it's a default one, but you can also here go to object, and that will just kind of extrude as far as to that object. Now, if you are in distance mode and are selecting stuff here, you can also click on a plane and then it will adjust it, but then that will just be a fixed number. This will always be the distance, and if that object moves, this will not be adjusted. If you want to adjust it, click to object, and then you can select the same thing, and that will automatically adjust later. Similar vein to extruding is revolving. That's just for circular features, but it's basically on kind of the same level of stability. I don't use this very often in guitar design, but if you have more circular objects, then that's a good choice as well. It's often a choice between revolve or an extrude, but either you kind of model this here, for example, from the back and then just extrude it out and get the cylinder, or you model it from the side and then you can revolve it to get the cylinder. Both are valid options, and it just kind of depends if you have more geometry that you want to add from the side or whichever. You can play around with that, what is your preference. Then the next one down the list, I would say, is sweep. You can just get it here as sweep, and here you can select a path, and then you select geometry, and then instead of extruding just straight out, your extrusion will follow that path. Here the scallops for the fretboard are one example where I want them to just kind of have this circular shape, but they need to follow the curvature of the fretboard and then kind of exit out in a nice swoop. So I designed the side profile view, that's what you select here as profile, and then the path, and that is a separate sketch. And then you select those two, and if you ever change those in the future, the sketches, then this will also update very predictably. Now you can just select one path, or if you want to have it adjust more, you can also select path and guide rail. So when you then select the second one, for example, if these two paths are slightly diverging, then the profile will scale accordingly. This allows you to create some quite complex geometry, but the more complex you get, the higher the chance is that it breaks if you change something further upstream. Very similar to sweep, and a thing that I actually use almost more often than sweep, is the pipe command. It is basically a sweep command, except your profile is always a circle. This is how I did the strings here, for example. So for these strings, I just have a sketch that is kind of the line where the string will be, and then in here it's very easy. You don't have to create a sketch for the circle. You just select your path, and then you select a section here. It can be circular or square, and the section size. So here it will be 0.01 inches for a number 10 strings. By the way, if you don't know the translation from the string number to the size is just in 1/1000th of an inch. So a 10 will be 0.01 or a 100 string will be 0.1 inches. Moving on to lofts, we are getting into much more powerful territory, but also into much more dangerous territory where you have to be a lot more careful. One example in guitar design where I use lofts a lot is for the neck. And here you can see kind of the main part of the neck, which is just basically a simple taper from one profile at the nut to a different profile around kind of the 12th fret is where I designed it here, but it could also be further up or further down depending on how you want to design it. This is an example of a loft that it works very well and is quite safe, because essentially we have two profiles that are very similar to each other, and it's perfectly clear for the program that here this corner is going to go to that corner, this arc here corresponds to that arc, so it's very easy to connect it, everything matches up, and there's kind of no ambiguity, and you'll get nice straight lines in between, and the geometry will be as you expected. However, if you have different shapes on both sides, then it kind of has to guess what part goes where. So the more different the shapes are, the more complicated it gets, and the higher are the chances that you're going to get some weird geometry that it was not what you intended. So moving on just a little bit here over to the heel, that's already a slightly more involved example. We still have fairly similar geometry. You can see that here we have an arc and 3 straight lines. Once again here we have an arc and 3 straight lines. But it's getting a bit more complicated because it's not just straight. Instead we are moving in kind of directions. So if I just have these two selected, then it will create some really weird geometry and it's not going to work well. So what I had to do here was adding some rails. This basically it gives Fusion some information of how you want to connect these two profiles. So you usually want to have kind of some at like the ends, and then sometimes you will also need ones in the middle. So let me quickly remove some of them to kind of. So now you can see that it still connects the ends nicely because I still have those rails selected, but here it wants to create some really weird geometry going up into here. That is of course not how I want to connect these two, but just the way that Fusion thinks, that's how it works. Now one way to correct it is by choosing here instead of connected, where it just connects to this profile, you can choose direction. And this will give you kind of a vector of how much it should follow that direction. But here in this case, that does not work very well. You can also, instead of selecting a sketch to loft from, you can select a face, and then it will give you some more options here that you can play around with, but in a lot of cases, it is quite finicky. But using rails, when we start adding these back in, you can see that it knows how we want to connect it, and then it will do those. How many rails you need is kind of something you have to play around with, or just to see how you get the geometry that you want. It can be sometimes a bit difficult to see exactly what the geometry is that you are getting. So I find for guitar design, applying a 3D wood material to it is a really good way to see, because then you have like the grain lines, and you can kind of see the curvature of things based on how the grain lines act. There's also more artificial things like zebra that kind of stripes it in specific ways according to curvature, but those require a lot more getting used to. So using wood grain is a really good way to visualize it as it corresponds to the real world object that you already know. Another thing that I sometimes use are section analysis. So that's this tool here. And then you can select a plane and you can kind of see how the section looks, and that's a really good way to kind of really go check if stuff is parallel and stuff like that. But that also gives you a limited view only. Then finally you will run into some geometry that just does not work with lofts. You'll try but kind of fail, and you just Fusion doesn't want to properly compute it because the two profiles that you're trying to connect are just too different. For example, here, this joint here, I want to create a very smooth transition in here that connects all of these things, and just like no good way to model this with a loft and get this shape. So in those cases, you can go to the surface tools. Now these tools can be great, however they basically don't really update with parametric stuff. Sometimes you can get him to update, but in a lot of cases you will have to go back into each one of the features and reselect some stuff and make sure that they are updated correctly whenever you change something further upstream. Like if I want this line further in, I will have to go into the operation that creates this shape here and go and change it. Giving you a full surface tutorial is not within the scope of this video, but I can just quickly show you how I make this joint. Let's roll the history marker back. I just have kind of the basic design without the heel joint. So basically what you would buy from Fender. And then first I have a sketch here that defines the line that I want to go to here. And then I use this splitting operations and I'm splitting a face. This will then essentially go from having a solid body into splitting stuff up. Then I create some more helping geometry and split some more faces here. That basically just is a way to kind of outline what I want to later cut away. Then in the next step, I go in and select all these faces and I delete them. Now this is where you deviate from the solid modeling that you have here, because now this is no longer a solid object. You can see inside, you can see the insides of these faces and the geometry. So this is not something that you could 3D print anymore with a CNC machine. But later we will make it back into a solid object. Then the next step is to create this surface here. And here you can just select all of the edges and then Fusion will try to connect them in the best way possible. Now, just like the Loft, this is in a lot of ways imperfect and it can work well if it's obvious, but if it's not obvious like this, then it will require some finessing. The main way that you can kind of influence the shape of this is either by using interior rails, just like in lofting, but a lot of times this will break and it will not be able to compute it. So I don't use this very often. The other thing is you can set tangency. On certain lines, you can say instead of being just connected, you want it tangent to how the previous surface was. So for example, if I chose edge 5 here, which is just connected because I want kind of an angle here, and I go from connected to tangent, then you see it will make it tangent here to this surface and of course balloon it up. But then you can also say kind of how far you want it to follow that tangency. By doing that selectively, you can kind of massage the surface in, but it's also often really hard to be able to properly see what exactly the surface looks like. And then finally, this is also not a perfect surface here for kind of the joint. I am machining this as I modeled it here, but then later go in by hand, kind of smooth over these corners, kind of cut it in nicely. Also kind of change that transition in here. It's just not worth it, the trouble to try and model that perfectly inside of Fusion when it's much easier to just kind of use some hand tools and finesse it until it feels good and doesn't just look good in the model. Then lastly, to get back to solid body, you can have to use the surface stitch where you just select multiple surfaces, and if they form a continuous body, then you are back to a regular body here, as you can see with this. And essentially with those kind of basic shapes that I just showed you, you can create everything. All of those together are basically all you need, and the surface tool is definitely kind of already a bit out there. Now you can also use kind of these mesh tools or more like form tools. I have not used those a lot, and there you are definitely outside of what is parametric. You can just kind of pull on corners to create your shape. If you want to get into that, you will have to check some other channels for tutorials because I really don't know how to use those. Now moving on to something a bit more light and fun that might be new to you and can enable some really cool stuff, but it's also kind of dangerous, and that's 3D sketches. One example here where I'm using them is for the strings, and let's just jump into the sketch here. The way you enable 3D sketching is just in the sketch palette here, you click on the 3D sketch icon after you've created the sketch, and then you will be able to not just place sketches on the plane that you designed them on, but also up into 3D space. Now, since you are using a 2D screen and 2D inputs, it is really hard for Fusion to know if you click here, where in 3D space you want that. Do you want that here on the surface? Do you want that floating above the fretboard here? That's why 3D Sketch is very dangerous, and you can quickly create geometry that is completely different from what you intended to do. So I really ever only want to use 3D Sketch when I'm able to fully constrain my lines. So I'm using the geometry that already exists as kind of reference points that I project into it. And actually, if you project into a 3D sketch, it's not going to pull it up to the line, but just going to give you the geometry inside of your sketch. So I have here from the barrel and then moving to kind of the point where the string sits on. Then here at the nut, I have all of the points where it interacts with the nut. And then the only thing that is not fully constrained is here the end. And these points here, I can just select, and you can try to drag and drop them, but that's just going to lead to jobble. So instead, you want to use the move command or press M on your keyboard. It's the same move command that you use for kind of objects, but now you can move these points in 3D space. So now, in this case, it's not working. Okay. So now that I removed the constraint here, I can move this point around in 3D space and can adjust where it goes. That's basically the only way that you're going to be able to create your geometry if you're not using kind of snapping it to points by just pulling on here and moving it this way, because dragging and dropping just does not work. But you can still use all of the other constraints like horizontal, vertical, parallel, equal, all of that stuff. That still works as well. Then once you're done, you can simply use these 3D sketches, for example, for pipes or for sweeps. That's really convenient. Another place where I used it here is the arm for the tremolo. As you can see, it kind of goes up and bends in different directions, and that was just much easier to create with the 3D sketch. But otherwise, I try to use them as little as possible, just because they are so finicky. The next tip is a little bit more of a serious one again, and that is about staying organized. Now, it might not be sexy to talk about organization, but it is very important. If you have a design as complicated as a fully modeled guitar, if you are not organized, it will be a pain to change anything. Now, it took me a lot of revisions to get to these files where I am now, and I went back a bunch of times. I had to restart sometimes, and basically the basic premise I landed on is having components for kind of the major components. For example, like the body, the neck. Now, the fretboard here is actually a separate component, and that is because I have like a master fretboard file that I just insert and then use that master fretboard file as kind of the starting point for modeling a new guitar. This way I don't have to remodel the fretboard every time I design a new guitar, because it's very similar, and it is also very easily you can also very easily use it with parameters. This here is actually my fretboard file, and this will also be available on my web store if you don't need a full guitar, but you kind of want to have a good starting point. And here it is. This is a model that is basically perfectly parametric. It's really, it sometimes can break if you change parameters in a weird way, but you can always go back and change them in a different order, and it will work. There's no kind of crazy stuff going on in here. So I can set the different scale lengths. Let's say instead of a slide fan, I want a much more aggressive fan. Let's go to 26.5 inches here. Hit enter, and then it has updated to a much more aggressive fan. But now I probably don't want the 0 fret here at the nut, but instead let's put it maybe to the 5th fret, and that broke it. So yes, as you can see, it can break sometimes, but if you're just going to play around with it again, it finds its way again. And now we have a nice fretboard here, 26 to 28 inches, with a like neutral fret at the 5th fret. And then I can just kind of insert that into a new design and start my guitar around that if I want to design a guitar with that scale length. And it appears that Fusion has just crashed. This demo effect is really not going too well. Huh, no, it did not actually crash. That's cool. Some of the things you can set in here are the fretboard radius, and it's fully compatible with compound radius. So if you want just non-compound radius, just set the same one for bridge and neck, or here I have going from 250 to 500 millimeters compound radius. I don't actually usually use compound radius on my actual guitars, but just this file here supports it as well. But that's enough for that. That is one good example of just kind of how staying organized can save you a lot of time. Not just am I using different bodies here for the different things, by having something that stays the same for basically all the guitars modeled separately, I can just simply insert it. Same goes for all of the hardware, like the bridges, the headpieces. That is all a separate model that I then insert. Now this can also be a double-edged sword, because if you then go back and want to change your hardware slightly for one of the builds, then basically in all of your guitars it will want to update it. Now it doesn't automatically update stuff if you change it, but you will get this little symbol here to update the component to the latest. So here I think this guitar, which by the way the video should be out hopefully next week about building this guitar. Here I modeled it earlier when I did not have the gem arm included into this bridge design, but then I later added it, so this is out of date now. Now I could update it, but since this is an older design, I'm just going to leave that alone. But that is something to keep in mind. I also like to have all of my hardware in a separate component, and this is primarily just so I can simply hide it. Now you can see that here I actually have a mistake, and that should be also in the hardware. But this way I can just simply get all of the hardware out of the way if I want to prepare the model for CNC machining, for example. And then inside of the hardware, a lot of it is also directly linked outside. I have of course the bridges, also have the pickups modeled separately. And that also means that in the file that will be available for you, it's going to be a single kind of archive file from Fusion360. But then when you upload it, I recommend uploading it to a new folder. And that way you get the main file, but also you get a file for the Atlas trim, you get a file for kind of the fixed bridge, and then inside of those files are actually having like these tubes are once again linked to a separate file. So you will also automatically get all of those. And for the pickups, I just have some Fishman Fluence as an example in here. But of course, if you get my pickup design files as well, you could insert them in here and change the cutout shapes to match that. Another thing that you want to be conscious of when designing is to kind of minimize the number of sketches that you are using. Now it is very tempting in the beginning to just kind of start a sketch, draw what you want, and then you're done with that sketch. And then if you want to add a hole into this outline, for example, just creating a new sketch on top of it, creating that hole. But then in the end, you're going to end up with 50 sketches. And unless you've been very diligent about labeling them, it's going to be really hard to know what sketch did what. On the other hand, you also don't want to over-color your sketches. Like you don't want to have one sketch here that defines the outline of the shape, but also defines the inlay and defines the pickups. That would be too much, and the sketch would not really be usable. So you want to kind of stay within the domain of the component, but combine as much as possible. You can combine that a lot with the different extrude features, where you kind of just extrude from the profile plane, but also with an offset or from an object. This way you can have one kind of top-down view and use that for all of your top-down body sketches and have all of them in one. The other thing, of course, is labeling. You can label sketches. Please label your sketches, otherwise you're going to have no idea what you're doing. What is less obvious, down here in the timeline, you can also keep order. You can see that this is a very complicated design, but I barely have to scroll to see all of the different timeline options. And that's because I'm making heavy use of groups. If you select with just Shift, a group of operations, you can right-click Create Group. This is going to create one of those things, and then you can also right-click and rename different operations. Now, these names don't usually show up, but if you see a bunch of groups down here and you want to find, oh, which one was the one where I did the scallops, you could just hover over it. So here I see, oh, this one is the one for the partial scallops, so I can just right-click on here and suppress these features, and then it's gone. And then inside of the group, all of them will be suppressed. That's not a good option. You don't have to delete stuff, you can just suppress it. And that means it will not be considered in the computation. But then you can just simply hit unsuppress and it is back. Now, if you have later things that are dependent on it and you suppress it, they will also be suppressed. So for example, if I take the outline sketch in the very beginning, this one, and I suppress this sketch, a whole bunch of other stuff is also getting suppressed because it is all referencing that sketch that now does not consist in the computation. So that's just something to keep in mind and be careful of. Then the last kind of design trick that is not really that much of a trick, it's a basic feature of Fusion. It's kind of how it is parametric and it's how everything is computed, and you can go back. And instead of having to go back into your extrudes, into your sketches all the time, if you have things that you know you might want to change, but you use in a bunch of different places, it's a really good idea to have the parameters. If you don't have this here, you can go down here, change parameters. And if you click on the hamburger menu here, you can pin it to the toolbar. And in here, you can just add something, give it a name. And then here, for example, these here are all from when I imported the fretboard into it. So this are the same options that you see here. But I also have a couple more, for example, the body thickness, pickup depth, stuff like that. Just makes it a lot easier to change things and go back. But of course, there is a caveat. And that is some stuff will start breaking if I change the design here too much. For example, if I now go in here and change the scale length to go all the way up to 27 inches, let's give it a second to recompute. As you can see, a whole bunch of stuff broke. There's 26 warning, 15 errors. Now this might seem intimidating and you want to just stop here, go back, but it actually, in a lot of cases, is just one or two little things that you have to kind of reselect, fix, and then it will work again. Now, this might be a bit of an extreme example as it starts colliding, but if we, instead of 27, let's just go to 26, that might be a bit more reasonable. Yeah, as you can see, that didn't break quite as many things, but there are still a bunch of errors and warnings. So that actually leads me to my next point, and that is how to fix errors, warnings, all of that nasty stuff inside of Fusion. If you work with Fusion long enough, you will run into a lot of these errors, and learning how to fix them will save you a lot of time. Now, generally, you want to start as early in the timeline as the first errors appear, but not all errors are necessarily all that important. For example, here, this is the fretboard design, and here it has, in this projection sketch, an issue. You can right-click on it, review warning. That will tell you exactly what is wrong with it. In a lot of cases, that is not that helpful, but there's a couple of things that you can have here. For sketches, compute failed is usually a common one. That is hard to know. That usually means that something changed and it doesn't know how to compute it. Sometimes these errors help you, but that just means you have to go into the sketch and figure it out yourself. But another common one would be missing points. That's if you deleted something in a reference sketch, or if you changed the body that the sketch was placed on, and some of the references are no longer there. That would be an easy one to fix. Or losing the sketch plane is another one. If you changed the body and it kind of lost the reference, then you can also reselect the sketch plane sometimes. But this one I don't think we actually have to touch for now. So the first one here is actually not an error, but I know this outline, something went wonky. And here you can see that for some reason, changing that because I had a parallel here, moved this line around in a weird way. So let's just move this back a bit. I'd have to adjust this more finely, but this should do for now. Then just kind of looking for the next thing that is wrong, I see here the belly carve went wrong. And this clearly went wrong here. Kind of looking into it, it looks that some of the sketches here have changed, where these lines didn't used to cross where they now do. So here is a case I have to go back into a sketch, kind of fix the sketches, and then in here I can reselect everything, and then that would fix this. Another common thing that gives you warnings would be fillets. And in a lot of cases, that's just because one of the edges changed, and it actually updated it correctly. It just gives you a warning because it changed and it doesn't know if it was correct. But here, actually, it still looks perfectly correct. So you can just go in, click OK, and then that got rid of the warning, but because it just kind of reconfirmed that yes, it is still correct. Then when you get errors like this, that's when you have to really do something, and that's oftentimes when there is stuff with kind of surface tools. So let's roll our history marker here. So yeah, as you can see, in this case, some of the lines have moved, and while it looked like they were still connected perfectly fine, somehow it was slightly off. Just kind of moving them and resnapping them into place has fixed this error in this case. And actually, the error was here on the split face, but the culprit was the sketch before it. Then moving forward, you can see that it updated, but here there's something weird, and here. And while this didn't give us an error, I can already see that the delete here didn't work. And actually not just the delete, but also this split face went weird, because here I think, yes, here this coincidence got lost. And as you can see, I was able to very quickly find what was wrong here. And that's because I fixed the sketch more than once before. So one of my projections here also got mixed up. All right, now this should be correct again. Now that's actually what I was trying to show you 5 minutes ago, and that is sometimes with the deleting face, it gets lost, it just loses one of them. Or I had this off quite often as well, where it kind of swapped them around. Just have to go back in, reselect it. And then now you can see that this almost matches up, but slightly off, and there's a warning here. And that is the surface patch that basically just never properly updates. But just going back in, reselecting the edges as we had them, clicking OK, that error is now also cleared up. Now this delve into fixing Fusion errors was a bit brief. It is just really hard to show exactly how, unless I specifically fabricate you the errors. But I also don't want to drag this video on too much longer, as it is already very long. So I'm going to skip further explanation, and you can play around it with yourself. The main thing you want to use is just kind of right-clicking on the feature to review the warning, and then if it's lost references, then you can usually right-click and re-establish the references. But otherwise, you just kind of have to figure out what went wrong, what kind of didn't adjust itself properly. And by fixing something, even if you have 20 warnings and 50 errors, sometimes you just have to fix 2 things and everything works again. Or sometimes everything is broken and you have to start over. That's just the life modeling stuff in Fusion that is a bit more complicated. But then finally, before we end this video, I want to show you another kind of fun, exciting thing. Here you can see the model for the Blue Rain guitar that I just recently uploaded onto my YouTube channel here. And you can see that I don't just have the regular generic Fusion wood appearances, but I have the actual top that it looks remarkably similar to how I ended up staining it. And the way I achieved that is by using decals. Here, by going to Insert, Decal, you can kind of apply your own textures to your design. And I find that especially helpful for visualizing how the wood will look. So my process for that is, if I have the piece of wood, I take a picture with my phone, try to have it kind of with the grain visible. So I use some like naphtha or mineral spirits to make the grain pop. Take a picture as straight on as possible, and then I take it into Photoshop and kind of make it sure that colors are correct. And if it is something that I will be staining later, I actually did the stain as an overlay in Photoshop. That's just kind of how it will be. And then coming into here, I then applied this as a decal. So I select all of the different faces that I wanted to be applied, select my image, and then you can kind of move it around to where you want it. hit OK, and that lets you visualize it. Here's another fun example that is an upcoming build, and as you can see here, the fretboard I have also imported it. The picture is not as great, but what this led me to do is I could show the client how will it look and talk about, does he want that much white, or maybe we should move it a little bit here. And this way I can very quickly provide a good visual, and you can go into the render space if you want an even nicer preview. And this gives you a very nice kind of visual representation of how will that wood look on the actual guitar in the end. Now if you make sure you scale it correctly, and sadly it always kind of is this glossy finish, and I have not found a way to apply a different finish to kind of your decals. They are always glossy for me, but I can live with that, as it's just kind of a really good tool to give you a preview. And with that, I want to throw the ball back to you guys. What did you learn today? What was interesting? What did you already know? Do you have any other tips and tricks for guitar design? Make sure to leave a comment down below if you also use Fusion for guitar design. And also, if you want to know more about it, there's great channels out there. I will have some linked down below, and you can of course explore a lot further. Also, if there's any aspects of the designing process that you would like me to talk more about, I can definitely go into that. I have not talked at all about the actual machining of it yet. If you want to get a preview of how I approach the machining of it, the file that is available does have some sample toolpaths in here in the manufacturing workspace. Now, depending on what CNC machine you have and what tools you're using, you will most definitely have to go back and change some stuff. Also here, just because I changed to the configuration, I believe I had it fixed bridge passive before. Some of my toolpaths have already kind of broken again, but in here you can see how I start off. This toolpaths here were from my Killer Bee CNC, so not the new one. But if you're interested, I can make a separate video about all of this stuff, probably then with my new CNC, and once I've gotten that figured all out. But for now, you can use this to kind of play around with it and get some ideas of how to do stuff better. So with that said, thank you guys for watching. Like, comment, subscribe, all that good stuff, and I'll see you guys next time.